Welcome everybody. I'd like to introduce you to Laura Smith. Laura works for the Royal Society of Chemistry and she's going to speak to you today about careers in chemistry outside of the lab. I'll hand over to you, Laura. Thank you.
Thank you very much, Vanessa, and thanks to STEMPOINT East for organising this event as part of Chemistry Week. It's great to be able to join you all today to talk about my job in chemistry, what it entails and how I got here. I've also included some resources at the end of the presentation which show you where you can find more information about careers in chemistry if you're interested. So, my name is Laura Smith and I work at the Royal Society of Chemistry, which has an office in Cambridge. I'm a publishing editor working in scientific journals, and I'll explain a little more about what that means shortly. Before we start looking at publishing and my job and background in a bit more detail, I thought it would be useful to introduce the Royal Society of Chemistry to you. Some of you may have already heard of us, and you might even be a student member. I've included a screenshot of our website because I think it's a really nice summary of all the things the RSC does. You can see the membership and professional community work highlighted at the top here, followed by the work we do on scientific policy. There's also our publishing work in journals, books and databases, which is what I do, as well as our teaching and learning resources and information about news and the events that we put on. The Royal Society of Chemistry is what is called a learned society. These exist in other subjects too, for example, the Institute of Physics, the IOP, or the Royal Astronomical Society, just named two. We are a not-for-profit organisation and professional body. Of all the activities listed here on this slide, the one we'll be talking about more today is our international publishing business, which is in green in the top left, just there. The Royal Society of Chemistry has offices around the world, with 2 in the UK and others in Europe, the USA, India, China and Japan. Like most of my other colleagues in publishing, I'm based at our offices in Cambridge, although you might be able to tell I'm working from home today. Next, I'm going to share some of the publishing activities that we undertake at the RSC. They span more than 50 journals across all of the chemical sciences, books, and I've included just 2 photos of front covers in the middle there, and database products including the Merck Index and ChemSpider. We also have our monthly magazine called Chemistry World, and for those of you who are members or student members, you might be familiar with this already. Before we begin looking at the academic publishing process and what an editor does in more detail, I thought I'd share a little about my background with you. Quite a while ago now, I finished my GCSEs in 2007, actually in Hertfordshire, and then went to sixth form college in Cambridge, and that's where I did my AS and A-levels. As you can see, they were really science-based. While I was doing them, I was working out what I wanted to do next, and I knew that chemistry was my favourite subject, so that was what I applied to do at university. I went to Durham University and graduated after 4 years with what's called a master's degree in chemistry. That's the MChem in brackets just there. In my final year, I'd been thinking about what I wanted to do next, and I felt there was lots of chemistry I wanted to explore in more depth, and I was interested in doing research. So that's discovering things that no one else knows yet. That's why I chose to do a PhD, which I finished 5 years ago. That was also at Durham University. Having a PhD is the reason my title is now Doctor. After I graduated, I joined the Royal Society of Chemistry and Publishing, and here I am. Before we go any further, I'd like to explain what I mean when I talk about publishing. It's specifically academic publishing, which refers to the publishing of research results rather than fiction, for example. This really top-level view shows how something can go from an idea or a hypothesis to a published, peer-reviewed article in a journal. So on the left here, researchers, for example, at universities, working in industry, or for governments or charities, perform experiments and conduct research, and can then decide that they would like to write up what they've discovered. Once they've drafted an article, they submit it to an academic publisher, such as the RSC, who will evaluate the work and decide whether to send it for something called peer review. Peer review is the process of experts in the same field assessing a researcher's methods and findings and providing a report on the work for the academic publisher. An editor, like me, will assess these reports and then decide whether the work could be accepted for publication, perhaps after revisions with the authors, so maybe they have some more experiments to do or some changes to make. Once accepted, the article will then go through various processes, including language editing and formatting and things like that. Finally, once it's been published, the article can be read by people around the world. I've highlighted in bold all the points where a publisher like the RSC may be involved. I thought it might be helpful to show what I mean by an article, so I've chosen a few examples of work that was published recently in our journals. All of the articles I'm showing you today are open access, which means anyone in the world can read them. You don't need special access via a university, for example. You can just search online for the title and you'll find it on our website. The first article I'm sharing with you is about using light to separate plutonium from uranium, which is really important for dealing with waste from nuclear energy, amongst other things. It's what we call original research or primary research. The authors had a hypothesis, which they tested with experiments, and then wrote up what they discovered as this article. We've only got the first page here. This is a short communication type of article, where the authors are sharing what we'd call urgent research with the whole chemistry community. This is from a journal called ChemCom, you can see in the top left just there, and that's one of the journals that I work on. Last year, we published over 2,500 articles in ChemCom, and this is just one of them. Authors around the world submitted about 7,000 manuscripts. That's what we call an article before it's published. And an important part of my job is assessing these submissions, deciding which to send to peer reviewers, and which of them we should accept after that. My second example article is a review, which was published in a journal called Chemical Society Reviews, or ChemSoc Rev for short, you can see at the top, and I also work on this journal. Authors who write review articles have read lots of primary research about a topic and want to summarise it and write about it in a way that will be useful for other people to read. Sometimes we call this secondary research because the authors haven't done any experiments themselves when they're writing it, but their article is based on primary research that maybe they or other people have done elsewhere. They are often experts in their fields and they might be well known around the world for the expertise that they have in this topic. This particular review is about carbon capture and storage, which you might have heard a bit about in terms of being relevant to carbon dioxide emissions and in global warming or climate change. Reviews are often much longer than primary research articles. That previous one I just showed you was 4 pages long, but this one is 20 pages long, and they can be much longer than that. My final example is from our flagship journal called Chemical Science. This is more original research. Some of these authors are actually based in Cambridge, which is one of the reasons I chose this example. This work is about peptides and proteins and how they fold. Some of you may have heard of things like alpha helices, beta sheets, and primary and secondary tertiary structures of peptides, and this work is connected to that. I hope these 3 examples have given you just a sample of the things we publish, as well as the types of articles that we're reading every day as editors. I'd now like to talk to you a bit more about what it means to be an editor. There are many different types of editor, and I've included some examples of the types we have at the RSC. You'll see publishing editor up in the top left in green. We also have copy editors, development editors, assistant editors, executive editors, and others. We also have associate editors, who are researchers working in chemistry around the world. They are typically academics or people working in industry, and they are experts in their fields. Oh, apologies. I also thought I'd show you some of the tasks editors can be involved in. I've highlighted those in green, which are particularly relevant to publishing editors like me, but you can see that there's quite a broad range of activities here. Starting in the top left, you can see a mention of the peer review process, which I've already talked a little about today. Working our way around clockwise, we have commissioning up there in the middle, which is editors inviting authors to publish their research with us. Some editors work with our editorial and advisory boards, who are groups of people that are experts and academics who help to lead our journals. Some also work in deciding the direction of our journals and oversee the science that we publish. Some of my colleagues work on promoting our journals, for example, at conferences or on social media. There are then a couple more things in green here, and as a publishing editor, I help deal with any ethical issues that may arise during peer review, and I also support associate editors working on our journals. Finally, some editors work on proofreading and copy editing, and that includes things like spell checking and making sure that the articles make sense. With that in mind, I wanted to touch on some of the day-to-day activities that I do as part of my role as a publishing editor. You can see there's quite a range here. I spend quite a lot of time working on and thinking about manuscripts, as well as talking to authors and reviewers. That's all here on the left-hand side. I'm also involved in various meetings, such as our daily editorial meetings, where we present and discuss the manuscripts we've been working on, and then decide how we should proceed with them. Sometimes I'll be assessing artwork and images that authors have sent in that they'd like to be considered for the front cover of a journal issue. That's similar to the front cover of a book. And that ties in nicely with the next thing on the list, which is the actual creation of an issue of a journal. So that's where we assemble all of the articles we want to publish in an issue and kind of parcel them up ready to be published. I've actually got an issue here with me, so this is what it looks like. One of the things I enjoy most about my role is working with associate editors, answering their queries and problem solving with them, as well as training both them and other colleagues as well. When I was finishing my PhD, I knew I was really passionate about chemistry and science, but that I didn't want to carry on working in the lab. So I started to think about careers that would enable me to use my degrees and my experience, but were more office-based. I've summarised 4 of the things I really like about working in publishing here. The first is that I get to keep really up to date with what chemists and other scientists are working on around the world. We're hearing about their latest breakthroughs and the results that they're really excited about. My job is really international. I work with colleagues in our Beijing office in particular, but I also work with authors, reviewers, associate editors all around the world every day. I feel that what I'm doing is really valuable. We help in deciding what research is suitable to be published and shared with the people who read our journals. And these readers use this information to direct their research and what they investigate. This research often has tangible, real-world benefits, and you saw some of those in the example articles I showed you, where people are working on processing nuclear waste or dealing with carbon dioxide emissions. Finally, no 2 days are ever the same. I work on lots of different journals and I get to see a really broad range of topics across all of chemistry every day. Finally, if you're thinking about what you want to do next and you're considering chemistry and not just publishing, I'd really recommend taking a look at this website, which is run by the RSC. The link's at the bottom there in orange. It's called A Future in Chemistry, Making the Difference. So you can also search online for that title and you'll find it. It's got loads of useful resources. It's got stuff about career options, like it's got job profiles, employability skills, what you can earn with a chemistry degree or chemistry experience. It's got information about work experience too. And then it's got a section about study options. So if you're 14, 16, and then older as well, it's got information about that too. There's a quiz that I recommend trying out, and there are also resources for teachers and career advisors as well. So oh yeah, I really recommend going to have a look at this if you can. To wrap up, here's a very brief summary of what we've talked about today. We started with an introduction to the Royal Society of Chemistry, as well as some information about my background and how I started working for the RSC. Next, we looked at academic publishing and what it means to publish an academic article, followed by a look at what a publishing editor does in their role. Finally, we finished with some information about careers in chemistry and where you can find out some more information. Thank you very much for your attention today. I'd be very happy to take your questions.
Thank you for that, Laura. That was great. Does anybody have any questions at all for Laura? If you could just pop them in the chat, or you can come off of mute and ask them out loud. Takes a little while, doesn't it?
Yeah,
so when you were at school, Laura, you always knew that this is kind of the road that you wanted to take, did you? Or did you ever want to be something else and you took a different path?
No, I don't think so. I think I always had an idea that I really liked science and science was what I wanted to do from fairly young. So I didn't have too much trouble figuring that out or thinking about it. And I appreciate that's not everyone's experience, but yeah.
It's nice to hear about that you can have a science career without actually being in the labs as well. That it just shows that a job has so many different roles within it.
Yeah, I had no idea about that when I was at school. I would have really liked to know about all the options.
So a student from Camborne School would like to know, what kind of grades do you need to get to be able to get into a chemistry career?
Oh, that's a good question. There are lots of different routes you can take. I know Christina's talk earlier today was about apprentice degrees and things like that. I took a different route, which was the kind of university standard degree route. And when I was applying, I think the grade requirements were probably lower than they are now. I would imagine some of the kind of maybe top 20 or so universities are looking for A's and A stars, I would imagine, in subjects like chemistry, perhaps maths, some of the other sciences as well. But lots of universities offer chemistry degrees, and I think there are lots of other ways you can get into it too. And plenty of places I don't think require A's and A stars, so you don't have to be getting, you know, the top results necessarily to have a chemistry career.
Okay, that's brilliant. Anybody got anything else that they would like to ask Laura before we end the call? If you don't have any questions, you are free to leave. Just going to find a link we had a feedback form. So which other industry could you go into with your degree other than publishing? Could you have
it's a great question. Yeah, that's just one option of so many. And I've got lots of friends who did chemistry degrees who went into loads of different other things as well. So quite a lot of people went to work in industry. So some of them work for pharmaceutical companies, or I think someone works for a paint company or companies that kind of do catalysts and stuff like that. Some of them have carried on in academia. So that's after you do a PhD, you carry on and you work towards becoming a professor. So I have friends who are doing that too. But you can also do other things as well. I know people who went to work in environmental science and stuff like that, but also people do things that are not science-based at all. Some people do accounting or finance or things like that. I know someone who is training to become a patent attorney. so more law-based. So there are loads of things you can do with a chemistry degree, because it teaches you so many different really useful transferable skills. You know, these kind of problem solving, analytical, thinking about what you're doing, those kind of skills are really great for lots of different careers.
Thank you, Laura. Okay. Were you always good at chemistry at school?
Tricky question. I think it always fitted quite well with me as a person. I think I got on with it. I've always liked maths and things like that. As you saw, I did physics and biology too, but I always found that chemistry kind of just fitted me better. I liked how real world and kind of, you know, you can see it and in front of you and stuff like that. I really liked it. So I guess maybe the answer to that is perhaps yes, but chemistry takes a lot of work. It's definitely not about natural ability or anything like that. You have to work really hard at it, just like you do other subjects as well, to be able to, you know, do well.
Thank
Welcome.
you. Okay, so I'm going to end the recording now. I have popped a link in chat to a feedback form. So if you have any more questions for Laura after we've ended the session, please feel free to pop them on the form and we will pass them on for you.